Before we start, I just want to go through again, like the main concept of what we have learned last week. Last week, we have learned about the concept of resultant force. And I say that resultant force is literally the result of having different forces acting on an object, okay? A result of having different forces acting on a same object. So it could sometimes be a very simple question where maybe if you look at this first example, both the forces are in the same direction. So the result would be what? A total of 17 newtons to the right side you add together. But there are times where maybe the force might cancel out each other. Okay, where we say that, let's say if I want to find out the result of one person pulling 12 Newton to the right side, one person pulling 5 Newton to the left side, what will happen? What is the result? It would be 12 Newton minus 5 Newton because it will cancel out each other. Okay, how do we minus? You always take the bigger force minus the smaller force to get the resultant force. Okay, you always take the larger force minus the smaller force to get the result of it. So at the end of it, this would be 12 Newton minus 5 Newtons to get 7 Newton only, right? Because they will cancel out each other. Okay, and it's 7 Newtons to the right, right? So using the same very similar concept, we have learned how to also draw a free body diagram. Okay, free body diagram where we will label all the forces acting on certain objects. Okay, right? All the forces acting on an object, and we have also dealt with elevator question. Okay, elevator question where we need to see and ask ourselves which force is bigger, which one should I minus to find out the resultant force and so on. Okay, so we're going to go back to where we stopped last class, which is at 1.8. Okay, let's go straight into this. The diagram shows Nadia standing on a weighing scale in an elevator. Nadia's scale reading is 50 kg. When the elevator stops at a certain floor, there's no stop, stops at a certain floor. Okay, what is Nadia's weight? To find weight, very simple. Can we go and do this? I think everyone should be able to do this now. Weight is the same as mass times gravitational field strength or gravitational acceleration, same thing. Okay, in any case, if you just want to convert the units of kg to Newton, you just times 9.81, right? Just convert kg to Newton times 9.81. You get 490.5 newtons. Part B. What happens to the reading of the weighing scale when the elevator accelerates upwards? Okay, maybe I go and draw out all the forces first. Okay, there is a normal reaction force and there is a weight. Right, the weight of the girl is pulling her down, but at the same time, there is something that will balance the weight of this girl, which is the normal reaction force. Right, this normal reaction force, if you didn't attend last week's class, you will feel very lost. Okay, that's why please watch the recording if you missed last week's class. It's in the Google folder. The normal reaction force is a force that will prevent this girl from falling down all the way, pass through the elevator and go straight into the center of the earth, right? So we need something to balance the weight, okay? And normally we call that a reaction force, right? If I press onto the wall, for example, there is actually a force from the wall that will support my force, right? Or else if I just press the wall and there's nothing supporting my hand, I would just fall into the wall, right? So you need to understand that the wall is actually also supporting my force. Therefore, I don't fall into the wall. I will just touch the wall like that only, okay? And then the wall will also support back. So that reaction force is normally called R, right? So there's a weight, and then there's also a normal reaction. Okay, so if it is accelerating upwards, Okay, if it is accelerating upwards, what is the resultant force? The resultant force will become R minus W. Okay, the resultant force will be R minus W, right? Why? If you are accelerating upwards, meaning the force pulling you up is stronger. Okay, the R is stronger. That's why only you can accelerate upwards, right? So the stronger force is always where it is accelerating towards, right? It can accelerate. Why? Because R is stronger. It's pulling up stronger. So I take the stronger force, the bigger force minus the smaller force. That's how you find out resultant force. Okay. And then elevator is, if you want to find out the reading, right? Reading is the R. Okay, we have talked about this last class. Reading is the R value. So if you go ahead and minus, if you go and move the W over, R is equals to, hold on. R is equals to not only the weight of the girl, on top of that, there is some force. Okay, so R is actually going to be, the reading will increase. Okay, the reading will increase. How come? Because the weight of the girl is W. On top of that, there is some force, extra force. So she will become heavier already on the weighing scale. Okay, the reading is not only just the weight, but on top of that, got a bit of extra things. Okay, number 2. What will happen if Nadia accelerate downwards? Okay, so now we change the situation. If it accelerates downwards, who is the stronger force? It is going down faster and faster and faster. That means the force pulling it down is the stronger one. That's why only it can accelerate faster going down. The W is the stronger one. So resultant force, you need to keep asking yourself, who is stronger, right? Where is it accelerating towards? That is the stronger force. Okay, F is equals to, I take W minus R, right? So the scale reading, the R, I can move to the left side. It would be R equals to W minus F. Okay, W minus F. So for part 2, the reading will decrease. Okay, why decrease? You see, normally her weight is just W only. But then now the reading is not only her weight, but also need to minus some F. Okay, need to minus some value. So her reading will drop. Okay, number 3. What if it moves downwards with uniform velocity? Okay, move downward, but with uniform velocity. So some of us may think like this. Some of us will say that, oh, I know that the resultant force, if it moves downward, that means the downward force is stronger. We will take W minus F. Because move downward, right? So we take W minus R. However, uniform velocity means acceleration is 0. Therefore, F also is 0. Okay, and your reading is just going to be W. So in part 3, the reading is unchanged. Okay, the reading will just be her weight. You look at part 1, the reading is not only the weight only, the weight plus some F value. Okay, that's why the reading increase. Part 2, the reading is not only her weight, but her weight minus a certain F value. So the reading decrease. Part 3, the reading is her weight. It's the same thing, right? So just remember, when acceleration is 0, the force has to be 0. Resultant force is 0. Okay. If you really, really want to memorize, you can think of it like this. You will notice something. Accelerate upwards. Reading also will go up. Accelerate downwards. you will notice the reading also will go down. Okay, the reading also will go down. Just so happen that it is the same way. When go up, your reading also will go up, also will increase. When go down, your reading also will go down, will decrease. That is if you really, really want to memorize, you can remember it this way. But you can always derive yourself by asking, what is the resultant force? Big force minus small force. And it's very easy to tell who's the bigger force. Okay, it's very easy to tell who's the bigger force. Part C, give a reason for your answer in part B3. Part B3, why is the reading unchanged? The reading is unchanged because uniform velocity means zero acceleration and zero resultant force. Okay. Therefore, W and R are balanced. There's no resultant force. When we say there's no resultant force, meaning there is no one force that is stronger than the other. Okay, you have resultant force whenever one side is stronger. But when they are the same, then resultant force is zero. Okay, they are balanced by each other. There's no stronger force. Okay, you minus is still zero, right? They are the same value. W and R are balanced. The reading is just the weight of the girl. Okay, part D, if the reading of the weighing scale in the diagram is 46 kg when the elevator is moving, it didn't say move up or move down. Okay, it could be up or down. They ask you determine the acceleration of the elevator. So right now they are saying that this 46 kg will become the reading. Okay, but let's find out 46 kg is actually how many. Okay, the reading. Reading meaning is R lah. Okay, so we do like this first. We say that, okay, R is 46 kg, but maybe I find out the value in newtons first. Okay, I find out the force in newtons. For kg, if you want to change to newtons, you just times 9.81, right? Okay, that is the reading. This one is the reading. Okay, so they say the reading is like this. They ask you to determine the acceleration. Normally for this kind of question, what do you always do? You always try to write the equation for the resultant force. Okay, so if the reading drop down, right, actually means it is accelerating downwards. Okay, it is accelerating downwards. Reading dropped means accelerating downwards. If you don't believe me, we can try and see. There's only two types. Your reading drop, if your reading change, right, it could mean that it is accelerating upwards or downwards only, right? Not. So you try accelerate downwards, see if it works or not. See whether the reading will drop or not. So if it accelerate downward, meaning the force pulling down is stronger, that's why it can accelerate down. So what is the force pulling down? W. Okay, force pulling down is stronger. W minus R. Right? And then the reading would be what? W minus F. Can you see or not? If it goes down, it will not only be the weight, but I need to minus some force. So going down, the reading will decrease. Okay, like what I wrote up here lah. Okay, if you, like I say, if you didn't memorize, this is all right. You just try both. You see which one can give you a smaller reading. Accelerate upward or accelerate downward. Okay, accelerate up, reading will go up. Accelerate down, reading will go down. Okay, so let's try to find out F is equals to MA. MA. The weight of the girl, we already found out from part A, is 490.5. The R we just found out is 451.26. Okay, the mass of this girl is 50 kg. We are looking for the acceleration. Okay, just move 50 over to the other side. Remember, F is always equals to MA. Okay, the weight already found in part A. The R we also found already, 451.26 newtons. You don't need to memorize one, you just need to know how to write if it's going down or going up. Okay, Ken? If you are done, you can go on to the next question, 1.9. Okay, Sharvina asks, if the lift suddenly stops to the ground, will the body stay still while the lift is dropping, or the body will fall off the ground, hence it will float off a bit? Drops to the ground. You mean when it's going down? Huh? When it's going down, your whole person will float up a bit. Okay, when it's going down, your whole person will float up a bit. Therefore, the reading will also drop. You are not pressing on the scale as much because your whole body float up a bit because it's going down so fast. Your whole body will float up a bit, and then the scale reading will be lesser a bit. That's why when you're accelerating down, the reading will also drop. Is that what you're asking? Yeah, okay. And then when you're accelerating up, the whole elevator is going up so fast that your body is pressing onto the scale a little bit. Okay, that's why the reading will increase when it's accelerating up. Okay, if you don't understand what I just said, it's all right. As long as you understand how to get the resultant force, then it's okay. Next question. A student weighs a fish on a spring balance attached to the ceiling. The reading of the spring balance is 4 kg. Okay, so this fish originally is 4 kg in the state of rest. What is the reading of the spring balance when the elevator moves upwards and downwards? Again, if you want to find out any reading, and all that stuff, you always need to do what? Write out the resultant force. Resultant force is who minus who, that kind of thing. Okay, so before you can do that, you need to go and write out all your forces. So we're going to draw a free body diagram. Okay, labeling all your forces on an object is called drawing a free body diagram. Okay, so you have the weight of the fish. You also have, normally we call this the R, right? Normally we call normal reaction, but can we call this the tension? Because the string is pulling the fish, correct? Okay, you can call R also can. You want to write R also can, but the better version of this particular question is tension, T. Yeah? Okay, don't ask me why they want to weigh the fish in the elevator, but okay, in this case you can use R or T. Okay, I will just use T because the fish is hung by this string or this rope, okay, which has a certain tension. So the reading is the T right now. Okay, they ask you for the reading, which is the T, T value, the tension of the rope or the string. Okay, so part A. If this thing is accelerating upwards, going up, how come it can go up? Is the T stronger or the W stronger? Can I have response from you guys? If it's accelerating up, is the T stronger or W is stronger? Very good. Thank you. Very good. Right? Yes, everyone is correct. Okay. It is accelerating up, so the T must be stronger. Okay. Very good, everyone. The resultant force is the stronger force minus the weaker force. That's why it can go up. The pulling force, the force pulling it up is stronger. Okay. So the resultant force is the strong force minus the weaker force. Okay, what are we looking for? We are looking for T. Okay, remember that we are looking for T. But what is F? F equals MA, right? MA, you write first. T is what we are looking for. What is W? W equals to mg. Okay. What is the mass of this fish? 4 kg. Acceleration, they already wrote here, 2 meters per second. Mass of the fish, 4 kg. The G value is always 9.81. Unless they tell you differently, you always stick to 9.81. I believe you can find out your T already. That is the reading of the scale. Okay, that is the reading of the scale. So this is going to be 8 equals to, if you are very fast, you can straight away calculate T lah. If not, you do slowly. The rest is not physics anymore. It's just maths anymore. Cherisha, you don't have to worry about the direction anymore. You don't have to put negative 9.81. Because when we do F equals to T minus W, right, we already consider stronger minus weaker. So don't worry about the direction anymore. The negative 9.81 we will use only when we are calculating the in Form 4, when we are calculating using the formula. Okay, yeah. So right now, we just use all positive values. Okay, all positive values. Okay, so T is going to be 8 plus 39.24. 47.24 newtons. Okay, that is the reading. But this one a bit special. Sometimes the scale, your scale balance, spring balance, sorry, it could be in kg. It could also be in newtons. Okay, but this spring balance is in kg. Can we change the reading back into kg? And right, you know how to change kg to newtons. You would times 9.81. Okay, so you go backwards is divide by 9.81. Okay, you will get a very long value, or you just write as 4.8, sorry, 4.82 kg will do actually. Okay, and just changing Newton back to kg. Can you know how to change that? So kg to Newton, you multiply by the g. Okay, if you want to change it back, then you divide by 9.81 to get the mass. Can you do the same thing for part B? You try and see yourself. Okay, now it is going to accelerate down. Ask yourself the same question. Okay, ask yourself the same question. Going down, who is pulling it down even more so that it can accelerate downwards? I always start every single question by doing this. Have this habit, you won't make mistake, man. Trust me. Yes, Pavitra, very good. Okay, if it's accelerating down, W is the person who is pulling stronger, the one that is pulling harder. Class, if up to this point, you have attended 2 classes and you still don't know how to write this, I think you need to revisit the recordings again, right? Because in the whole class last week and the whole class this week, I keep on asking you the same question only. The result is the bigger force minus the weaker force. Every single question, we keep on writing this only. Okay, you need to know how to write this. Everything else is not so important. The step down here actually not so important. You just need to get this right. If you can get this right, everything else will come naturally. Okay. So F is MA, W is mg, T is the value that we are looking for. Okay, do yourself slowly. This one is just maths and moving things around. No big deal. And then you can get your reading in here. Bear with me if I keep on repeating the same thing, because if you understand, that's very good for you. But in Tuesday's class, something very sad happened. After 1 hour of the class, one student asked me, how did I get F equals to W minus T? At that moment, that was like the saddest point of my day. Because I told the student that, oh, this was something that I kept talking about in the last two classes, right? So, and that is the most important thing. If you can't get that, the whole question you cannot do, right? So you need to know the idea of larger force, smaller force. I hope no one is left behind. I hope everyone can follow along and know what is going on. Oh, okay. If you don't understand why we need to divide by 9.81, it is just a conversion of units from Newton to kg. Okay, it's from W equals to mg. So if you have 31.24 as the weight, okay, in newtons, and you want to find out the mass, and g is 9.81, to find out the mass, you can just divide it by 9.81. Okay, it's W equals to mg helps you to convert from weight to mass, or mass to weight, remember? Yeah. Okay, you'll get this very long value, but I think 3.18 kg is good enough. So you should be able to see a very clear difference. When it is accelerating upwards, okay, reading also go up. It's no longer 4 kg, but it's now 4.82. If it's accelerating downwards, reading also will drop. Okay, reading also will go down. Okay, now, elevator question is very, very popular. You most likely will see it in your exam. Okay, it could be an objective, it could be a whole structure question. Yeah, this chapter has a lot of calculations. This chapter, okay, a lot of calculation. Okay, now let's move on. Okay, so you have elevator, and I hope you have mastered that. Okay, how to see the resultant force is which one minus which. The next part is we're going to go into the pulley systems. Okay, a lot of people will find pulley system very confusing, but you try to follow along. Try to focus when I explain this and try to follow along. Okay. So they say consider the following pulley system, and they also say use the gravitational acceleration of 10 meter per second squared. So in this particular question, we're not going to use 9.81. I'll just follow the question and use 10 meter per second squared. Okay, I think they just want to make our life easier because right now I just want to explain the concept, not so much on calculating the actual value. I just want to explain the major concept. Later we'll do some questions. Okay, we'll consider the pulley on the left side first. Okay, this pulley. First one, find the resultant force. Okay, find the resultant force. I want you guys to focus on the rope, the rope that is connecting this. Okay, I want you to focus on this, the rope that is connecting this blue color one. Okay, if you have a highlighter, you can also highlight this. Okay, we are focusing on this whole string here, right? Can I ask you guys a question? logical question. If you have a pulley system like this, left side 4 kg, right side 3 kg, the weight they already calculate for you, 40 Newton and 30 Newton. Okay. Can I ask you guys a simple question? Which side will the whole pulley go? Will it come down here in this direction A, or will it come here in this direction B? Which one will it be? Like if I give you a system like this, which side will it go? Okay, most people say A, got one say B. I think you would say that it's B because it looks like it's lower. Okay, but take a look at the value. Take a look at the value of the weight. Who is the stronger force? 40 Newton, am I right? Okay, would you agree that 40 Newton will be the one that is stronger and therefore pulling the whole system to one side? Okay, right? The 30 Newton is also trying to pull. 40 Newton is also trying to pull. But at the end, who will win? The stronger one, 40 Newton. So it will follow and come down in this direction. A, the answer is A. Okay, logical. The stronger force will win. Correct or not? The stronger force will win. All right. So the resultant force, if you want to calculate, is like this. Okay, you imagine one person pulling here, one person pulling here. Okay, one person is pulling 30 Newton, one person is pulling 40 Newton. Who will win? 40 Newton will win, right? And how do I calculate the resultant force? I'll take the big force minus the smaller force. Okay, because looking at this blue color line, the one that I highlighted, the blue color line, 40 Newton is going this side, but the 30 Newton is fighting against it. It's making it, it's slowing it down. It's fighting against it. Okay, next one. Find the moving mass. The moving mass means the total mass. Total mass. Okay, later I explain why we need the total mass, but it's 4 plus 3 kg. Okay. Next one, find the acceleration. To find the acceleration, I will use the formula F equals to ma, because I already know the F. Okay. And the M is 7 kg. And I'm going to look for the A. So I'll have a lot of students ask me, why am I using the mass as 7, not 4 kg, not 3 kg? Okay. Yeah, isn't it coming down from the 4 kg side? So shouldn't the mass be 4 kg? No, you think like this. The resultant force is pulling this force that you have, this force that will win, this resultant force is pulling who? Is pulling what? Okay, everything that it pulls should be included. Every single mass that the force pulls needs to be included. Okay, the resultant force is to see what is the stronger force and who will win eventually. But that force is not pulling 4 kg only, right? That force is not pulling 4 kg only. That force is also pulling the 3 kg plus the 4 kg. Okay, that force, this force is pulling a total of 7 kg. Okay, this force is pulling a total of 7 kg. Right? I hope I clear any doubts that you have on why I use 7 kg instead of 4 kg or 3 kg. Okay, so acceleration would just be 10 over 7. And that's it. Right? So this whole part is for the whole system. Okay, it's for the blue color one that I highlighted, the entire system, for the whole pulley system. Okay, for this whole situation. Right? So just remember the mass you need to calculate or take every single mass that will end up moving, the moving mass. Okay, next part, we'll look at the string tension. So some people will ask me, right, teacher, you have tension going on here, okay, tension that is here. First of all, let me talk about the direction of the tension. Tension is always to the center of the pulley. Okay, tension is always to the center of the pulley. How come? If you have a weight like this, 3 kg, okay, the weight is pulling it down. Something has to balance the weight, right? And if you are pulling it using a string, we call that the tension. Okay, instead of normal reaction, we call that the tension. So it's always in the opposite direction. So, or you can just remember it as tension always pointing to the center of the pulley one. The center is here. This one's the center. Okay, we don't say the tension is going down. Nope, the tension is pointing to that round circle. Tension is to the center. Center is here. Okay, right. And then some people ask me this, teacher, if I'm looking at the whole system, how come just now I didn't include the T? Okay, how come just now I didn't include the T? So you look at it like this. If I go and draw the T into this situation, right, the tension will be like this. They will perfectly cancel one another out. Okay, they will perfectly cancel each other out. So if you look at it as a whole system, you won't be able to find out the tension. Okay, if you look at it as a whole system, it will cancel each other and you won't be able to know what is the value. So what should I do if I want to find out the tension in this question? Okay, there are two ways of looking at it. Okay, I will focus on cutting this whole situation into half and doing it separately. Okay, you see, so you watch and you draw this out as well. I'm going to focus on the 4 kg only. Okay, I'm going to focus on the 4 kg and I'm going to draw the free body diagram of the 4 kg. Remember, I can find out the resultant force for any object. It could be the whole system. It could be one object, right? It could be the 4 kg mass. It could be the 3 kg mass, right? So right now, I'm looking at it as a smaller sub-question. So one question I can split into 3 situations. The whole system, that's one. The 4 kg side, that's one. The 3 kg side, that's another one. Okay, so let's focus on the 4 kg only. I have the weight, 40 Newton from the diagram. I also have the tension. Okay, this is all the force that is acting on this 4 kg. There's nothing else, right? 4 kg only got the weight of the 4 kg and as well as the tension pointing up. Okay, can we also put down the acceleration of this 4 kg? How fast is your 4 kg traveling? We already found out just now, 1.43 meter per second squared. Okay, this is an important piece of information, right? Because if it's accelerating down or accelerating up, the way I minus is different, right? Accelerating down, stronger force is down there. Accelerating up, the force up there is stronger. Okay, so I'm going to say that the resultant force is actually the same as, who's the stronger force? Can you all tell me who's the stronger force in this case? Accelerating downward, the 4 kg. Yes, W. Okay, very good. W. You can see the whole system like this, accelerating up here, and then it's not accelerating down. And I already found out the acceleration just now. Okay, it is 1.43 meter per second squared. Right, so F is equals to W minus T. What is F? F is equals to MA. What is W? 40 Newton. What is the tension? Tension is what we want to look for. Okay, tension is what we want to look for. Again, now I'm focusing on the 4 kg only. So mass is 4 kg. Acceleration, how fast is this 4 kg moving? This 4 kg is moving at 1.43 meter per second squared. This way you can find out your tension again. The bottom step, not important one. The most important step is, do you understand this or not? Okay, if you don't understand this, the stuff at the bottom don't mean anything. Yeah. I get 5.72 equals to 4 minus T. So the tension, negative T, I move to the left, become positive T. Right, so there are two ways to look at it. I've just cut this whole system into half, just focusing on one object. I can also focus on the other objects. Okay, practice to draw your free body diagram, because SPM can ask you to draw the free body diagram. Okay, which is a simple object and label all the forces acting on it. Right, but you look at the diagram just now, remember you all say that the whole system will travel towards the 4 kg side, right? So the 3 kg will actually move up, correct now? Okay, the whole system go like this now. The 4 kg will go down, but the 3 kg will go up. And then you all try again to do the same thing. Okay, resultant force is what minus what? Okay, Charisha asked me if this isn't the tension of the whole system, why do we use the A for 7 kg? Oh, the A, Charisha, this acceleration is the acceleration for the whole thing. How fast is your 4 kg moving? 1.43. How fast is your 3 kg moving? Also 1.43. Right? I know it's for the whole system, but am I right if I look at them individually, they are traveling this fast? Right? They are traveling this fast. So normally we will find the acceleration from the whole system, and we'll find the tension by splitting it into half. Splitting the question into half. Yeah, I know the acceleration of the whole thing is moving like that. But if I look at 3 kg itself, 3 kg is memang moving at 1.43 also. Yeah. Right. So F is actually T minus W. I hope you can get this. This is the most important step. Okay, this is the most important step. Yeah, again, F is what? F equals to MA. Resultant force is always MA. The weight is 30 Newton. Okay, if they haven't calculated for you, then you just do mg, right? If they calculate for you already, then you just follow 30. The mass, remember, just look at this diagram right now. We are focusing on one object only. Okay, I know the last decimal is a bit different. That's all right now. That's all right. Because just now we rounded off the acceleration already. That's why the value may be a bit different. But this tension should be the same now, right? Which makes sense because they perfectly cancel out each other, just now we say. And also, logically speaking, you think they are the same rope. They are the same string. If it's part of the same string, how can the force be different, right? The same string will share the same force. Okay, it's part of the same string. This pulley question is important. This one here. Okay, so I can look at the whole system as a whole, or I can look at a particular object. Normally, we look at the particular object just to find the tension, because if you look at the whole system, the tension cannot find one. They will cancel out each other. Okay, you take T and then you minus T and then they cancel each other. One. You won't be able to find it. Okay, let's look at the second situation here. You also have this kind of pulley system that the question can test you. I also want you guys to highlight this, if you can. Highlight like this. Okay, highlight like this. This is the whole system. Okay, this is the whole system. When you find out the resultant force, right, you only need to consider this light blue color one. Anything in this light blue color one. Okay, anything in the direction of this light blue color one. Because the resultant force will just be 30 Newton. I know the whole system will travel like this, huh? Right? It will accelerate down, go down. Huh? It will be very scary. Can you imagine? Some people say, oh, teacher, this one 4 kg, so it will travel upward like that. What did you learn in science? What happened to gravity? So it doesn't go up, please. It goes down. Okay, it goes down. Right. So the resultant force is actually 30 minus 2. 30 minus 2. Okay, I will have a lot of questions now. This is the confusing one. Okay, I need your utmost attention and focus. Okay, like this. The 4 kg doesn't affect the blue color movement because 4 kg, I know if you convert, it will be 40 Newton. Let me use a color that you can see. 4 kg, if I convert, it is 40 Newton. This 40 Newton does not matter. Okay, this 40 Newton does not matter because it is not on the blue color path. Then what happened to the 40 Newton? 40 Newton is actually balanced by the normal reaction force. Can or not? Okay, the 40 Newton is balanced by the normal reaction force. So I have a 30 Newton pulling it down, and there's only one force which is slowing this 30 Newton down. There's one force that is fighting against it, which is the frictional force, the 2 Newton. Okay, then also I will have questions like this. Then teacher, does it mean I can put any weight here? I can put 100 kg, 200 kg here, and it doesn't matter. You are kind of right and kind of wrong. If you put 200 kg, what happens is that you will just make the friction even more. You will create more friction. Okay, can you imagine if you put something heavier and you try to pull it, the friction will be even more. Okay, so the mass here doesn't affect it directly. Okay, it doesn't affect it directly, but it will produce some friction now. And so that is why you only look at the blue color line for the whole system. The R and the W, they perfectly balance off each other already. It doesn't affect the resultant force. Okay, right. And then you have the moving mass. And here's the confusing part also, because in total, this force is trying to pull what? Okay, the force is trying to pull not only 3 kg, but also 4 kg. So remember, the force, you are just looking at the one that is along the pulley system, along the string, but the mass is the total moving mass. Okay, the total moving mass. Again, because this force is pulling a total of 7 kg as well. Okay, that's why you need to include all 7 kg, not just 3 kg. And now you can't ignore the 4 kg already. Okay, it is pulling the total 7 kg. Okay, again, this is for the whole blue color system. And to find out the resultant force, you go and draw all your W lah. You see whether it will affect or not, whether is it along the blue color line or not. Okay. In that case, you will already perfectly cancel out with the R, the normal reaction of that one. Okay. Trust me, this part of the chapter is probably like one of the most difficult part already. Many years, every single year, this thing they learn from the old syllabus until now. For many years, a lot of students always don't understand this part. A lot of people, they don't know how to do this one. It's very normal. Okay. But I hope everyone in the class know what's going on. Okay. I hope everyone know how I go and find the mass, why they balance out each other. Yeah. Yeah, you just go to school, right? When school reopens, and when you relearn this, you will notice that hey, actually a lot of people around me don't really know what's going on for this pulley system. Okay, so I just hope you're not one of them, huh? Okay, I hope you understand. And if you ever forgot any of the key concept, just go and look back at this example. It will tell you everything you need to know. Okay, and in SPM, knowing this two pulley system is already good enough. Okay, right. Find the string tension. Again, look at the direction of the tension. It is towards the center of the pulley, okay? And they will perfectly cancel each other, right? One go up like that, one go down like that. So cancel out each other. So the resultant force for both the tension is zero. The result is zero. So I can't look at it as a whole system. I need to look at one object at a time, all right? So let's look at the 3 kg first. Let's draw the free body diagram again. Very simple diagram. You have tension going up, and then you have the weight of this one, okay? And then overall, right? Overall, your your block is moving at 4 meters per second squared, right? This one is moving at 4 meters per second squared. This is how fast it is accelerating. Okay? This is how fast it is accelerating. And then, right, same thing, we're going to write out the resultant force of this 3 kg block. Okay? If it's accelerating down, it is W minus T. Okay? F again is MA. W is 30 Newton. And you can find out the tension already. The mass is 3 kg because I'm focusing on the 3 kg only. Acceleration is 4. Okay, this 3 kg is accelerating down at 4 meters per second squared. Right, so the tension of the string is 18 newtons. And then here comes the interesting part. The 4 kg block. Okay, you have the tension going this way. You have a friction, 2 Newton like this. Right? Some people may say, teacher, there is also the weight. Yeah, right? There's also the weight. But the weight perfectly balanced by the normal reaction already. Okay. Balance. Right? So the R and the W is like kind of in their own world. It doesn't affect the acceleration of it going to the right side. Huh? Okay, the weight of 40 Newton is already balanced by the normal reaction R. If you want to know what is that value, it is also 40 Newton. Balance, right? It has to be the same. So just ignore the R and the W. If you don't draw that in this question, it won't affect. Okay, and then and look at the whole system. Your 4 kg is moving to the right side. It's moving to the right. It's accelerating to the right. Therefore, if you look at it like that, F is actually just, okay, the result of it will be the stronger force is going to the right. The stronger force is the tension, the one that is pulling it to the right, minus the friction of 2 Newton. Okay, the friction of 2 Newton. You want to write friction also can? Straight write 2 Newton also can. Okay, and then F is MA again. What is the mass of this 4 kg? How fast is this 4 kg moving? 4 meters per second squared. Yeah, okay, that's why I always say if you want to save a copy of the notes yourself, you can save a copy. And if you want to reprint and redo again, you can always do it. Okay, you want to reprint and later on want to try yourself again, go ahead. Okay, go and save one copy because after a few weeks, I will remove the file. Okay, so if you want to save a copy on your own, later on want to reprint and redo again, you can. Because I always tell my students this, if you can do every single question on the notes, every single question, like those who have joined since last year, you know that my notes have a lot of essay, got objective, got structure question. If you can do every single question without referring on your own, I don't see a reason why you can't get A+ in SPM. Okay, because the questions I use are SPM questions, right? Even if I find it from like exercises and stuff, it is from questions that I've analyzed through looking at the past years, looking at the state papers. And a lot of questions are from the state papers, right? A lot of questions are actually real SPM question papers. So yeah, if you can do every question without referring on your own, I don't see why in exam you can't score. Because if you can do everything on your own, meaning you understand the concept. Okay, physics is a lot on the concept. You know, and in this topic, it's just big force minus small force. Okay, we'll take a break here. And we'll take a short break and we will come back again in 4 minutes. Okay, so water break time, toilet break, you need to do anything, go ahead. Okay, we'll come back in 4 minutes. Say 9:05. Huh? I need to remember to record. These days I've been forgetting. Okay. Okay, next question. Page 1, question 1.11, page 7. Consider the following pulley system used to carry heavy loads A and B. The mass of load A is 8 kg, okay? And then B is 12 kg, okay? Calculate the acceleration of the loads. If you can recall, normally from the previous question, usually the acceleration we can find from the entire system, right? When do we need to split it into half? When you're looking for the tension, because the tension will cancel out each other, right? So the first thing I would do, which is a good habit, is to go and draw out all the forces that is affecting your system here, okay? All the forces acting on this system. You have two different weight, okay? Let's call it WA and WB. Okay, you have two different weight. And then you also have tension of the string, which is pointing towards the center of the pulley. Okay, right. I think that's all. calculate the acceleration. Let's write down here because later part B will be we need a bit space there. You know what? Let's just straight away try to do the usual thing that we always do for the elevator question, which is try to write out what is the resultant force. Okay, try to write out what's the resultant force. I'm looking at the whole system. Okay, I'm looking at the whole system. Yeah, why so ugly? Okay, I'm looking at this blue color system here, right? Where it is accelerating and how, and every force that is affecting it. Okay, so I think, should I take the load B minus A or A minus B? Right? Who is stronger? Confirm the heavier one is stronger. Can I agree? Confirm the heavier one is stronger. So in this case, WB, yeah, Vashani, that's good. WB, the stronger one, will minus WA because the load A is trying to slow it down. Okay, load A is trying to slow it down. Therefore, strong force minus the weaker force. Okay, it's like if you open it up, you have WB and WA like that fighting against each other. Okay, both also pulling and both also fighting against each other, and WB is the stronger one. Okay, so big force minus small force. What is resultant force? MA. Okay, what is the weight of B? The weight of B would just be 12 kg times 9.81. What is the weight of A? The weight of A is 8 kg times 9.81. Okay, weight is just W equals to mg. Right, just converting kg to Newton only. Next question, what is the mass? I can't take 8 kg. I can't take 12 kg because I'm looking at the entire system. The entire system, what is the total mass that is accelerating at the same time? In total, this force in total is trying to move 20 kg. Okay, in total, this acceleration or this force is able to move 20 kg in total. You need to include all the mass that is affected by this force. All the mass that is affected by the force. Okay, Ken, in the previous table, I call that the moving mass. Okay, the moving mass. Okay, you can calculate this one. You can just type the whole thing in the calculator. You can count one by one, but it's just 39.24. And then 20A is 39.24. Then you can find out A already. Okay, I think I'll just write the whole thing. This is in meter per second square. Make sure you have your units. Okay, earlier on in the table, I tried to teach you very slowly. I broke it down one by one. Why the mass, I must use that. Why the acceleration, I need to calculate like that. But normally, if you do a certain question, you can use the elevator concept. Find out resultant force is who minus who. Okay, can. Part B. Calculate the tension of the string. There are people who ask me, the tension, can I include here or not in the resultant force? You can, okay, but the tension, right, is very redundant one because you add the tension, okay, the tension, and then again you need to minus off the tension. Why? Because they are facing each other, they will cancel out each other, so you will plus a tension, and then after that you will minus back a tension. Can see now, right? So it's very redundant, so you don't actually have to write this. Okay, so I don't want you to think like, why am I considering the whole system but don't have tension? Tension is there, it's just that it doesn't affect. Okay, so you don't have to write it. Part B, calculate the tension of the string. Now I need to look at it one system at a time. Sorry, one object at a time. Block A is 8 kg. Let's label all the forces. You want to do for block B also can. Okay, label all the forces as well as the acceleration. Acceleration is very important. This block is moving or accelerating this fast. Okay, right? And you need to know the direction of the acceleration. That's why I say acceleration is important. Then only you know is what minus what. Okay, so state all the force plus the acceleration. That will help you. So let's try to write it out. Resultant force is the bigger force pulling up one minus the smaller force. Okay, what is the force? F equals to MA. You can go and try to do yourself. We're looking for the tension. What is the weight of A? It is just 8 kg times 9.81. Okay, the mass that you're looking at right now is only 8 kg. How fast is this 8 kg accelerating? 1.962. And there's a reason why this is in Form 5. It used to be in Form 4. It used to be in Form 4, Chapter 2. So this is force and motion, right? Chapter 2 used to be very long last time in Form 4. They used to combine together, and now they split it out. So if you imagine you Chapter 2 straight away learn this, you're gonna, I think you guys will feel like, why is physics so difficult? That's why last time, right, Chapter 2 need about 3-4 months to finish on, because it's very, very long. Yeah, it's the longest chapter, but now they split up already. Okay, tension would be 94.176 Newton, or you want to write 94.18 also can, right? Since this is just a practice, like we are in class, let's also try to figure out what will happen if I try using the other one. Okay, the other block. Let's see what will happen. Huh? Okay, just practice and see if you can get the same answer. Have a good habit of drawing the free body diagram, because question can ask you to draw. And also putting down the acceleration is helpful. Oops, it's going down. Huh? No. Don't copy my answer, just do yourself. Huh? Just practice on your own. The rest is easy lah. Just type calculator only. Yeah, both the tension in this case is exactly the same. So you know you're working and everything is correct. Okay, so you see in one question, I can look at it as a whole system. I can look at it as just half of it only. Okay, normally I need to cut into half or look at one load by itself, because tension will cancel each other if I look at it as a whole system. So you want to find tension, you normally need to split up. Okay, if you want to practice more, right, you can also go to the objective question. There got quite a few that you need to do calculation on. You can try. Okay, everyone good with this? I move on. 1.12. A 2 kg trolley is connected by a rope to a 3 kg load. And then the rope passes over a smooth pulley. The load is then released. Okay. If they say smooth means what? No friction. Yeah, no friction. Okay, no friction. Yeah, right. No friction. That's good. And then calculate and label the weight of the 3 kg load. Okay, so let's try. Find out the weight of the 3 kg load. Weight is just very easy only. Kg change to Newton. How to do? M mass times gravitational field strength or gravitational acceleration. (29.43). They asked to calculate and also label. So I'll go to the diagram and I will label this one as W equals to 29.43 Newton. So later when we need to use it, we can straight away use it. Part B, label the tension of the rope on both sides of the pulley. The tension of the rope, the tension is here. The tension is also here. And then label the direction of the acceleration for the 2 kg trolley and the 3 kg load. Right. So you see this question is trying to guide you. It's trying to set for you or set up this whole question very nicely for you to tell you where's all the force, to tell you where is it accelerating towards, right? Your acceleration is like this. And then for the 2 kg load, the acceleration is like this. Okay, 2 kg and 3 kg. So the whole thing is moving down because got the gravity. Part D, if the surface of the table is smooth, okay, if the surface of the table is smooth, what is the acceleration of the trolley? Hence, find the tension of the rope. Okay, so you can try yourself if you feel that you're okay. You can try yourself, but I am going to look at the whole system first, the system as a whole. Hold on. Okay, I'll look at the system as a whole, meaning this light blue color one. Okay, let's try. So F is equals to what? Okay, F is equals to what? F is equals to 29.43 minus 0, right? Or you can do like this. You can do the W of the 3 kg. Let me put a little tree here. Minus, there's no friction. There's no friction. So 0 Newton. There's no friction here. Okay, I know some of you will start to ask again, teacher, what about the 2 kg? The 2 kg doesn't affect. Okay, because it is balanced by a normal reaction. It is kind of like in their own world, right? So just focus on anything on the light blue color line. Can see it? Look at the light blue. I purposely highlight for you. That's the whole system. So what is affecting the acceleration? Not the 2 kg. Just the friction with the table as well as the weight, 29.43. Okay, so the resultant force is 29.43 minus friction, which is 0. You don't write this also can. And then resultant force is F equals to MA. Okay, but what is the mass? Not 3 kg, not 2 kg. The overall mass that is affected by this force, 5 kg. Okay, the total moving mass. Okay, the total moving mass, 5 kg. Yeah? Okay, and then you can try also to find out the tension of the rope. This is when you need to look at it one at a time, right? Like I said, there's actually tension here. It's just that they minus off each other, right? So you can ignore. So since I can't find it when I look at the whole system, I will look at it one object at a time. Okay, maybe I do for 3 kg. Right, it is also useful to write down the acceleration. So the resultant force for this system, if you know, you try yourself, you don't have to wait for me. Okay, I'll let you do it. It's gonna be like this. Okay. I'll do both version of it lah. There's also the 2 kg one. Okay, try to calculate the T on your own. There is no friction. And then you can label W also. Okay, sorry. W and R. Hey, what am I doing? W and R, which perfectly balance out each other and doesn't affect the acceleration. Okay. For those who have gotten their answer, it should be 11.77 newtons. Okay, 11.77 newtons. If you're done, you can try part E. Okay, if you're done, you can try part E. You will notice that if you use the 2 kg trolley, it's even easier because it's just tension minus 0 Newton of friction. Okay, friction that is 0 newtons. And you get 11.772 as well. Or just 11.77 also can. Okay, part E exactly the same, just that you have friction now. Okay, I hope you did. F equals to 29.43 minus 10. Resultant force is the weight minus, now the friction is going to be 10, the one that is slowing the acceleration down, right? Just look at the blue color line. There's nothing else that affects how fast it is accelerating, except for the friction and the W. Okay, the T is in its own world. It cancels out each other. The 2 kg, the W and the R is again in its own world. They cancel out each other. Okay. The mass is the total mass. Okay. When you have friction, you see overall it slows it down already. And then you can do either version of it in exam. Just do one will do. But let's say in practice, you want to do a bit more, go ahead. I think you should do both in your notes, okay? So that when you look back, you know how to do, you know what is going on and you know both ways. Okay, this one, the force is P minus 10 newtons, and then F is equals to, I hope you got your answer already, huh? Okay, this one you should be able to do yourself, huh? Okay, so both ways also can, you will find you get the same value. Right, these two are the most important pulley system. If you want, you can go and try like question 7, question 8 in the objective questions. And then question 16 also can, that's the lift question. Right, the rest of the question are a lot of it is very much on the theory only. Okay, if you need to, go ahead and rewatch the recording if you find that it's still very all over the place for you. Okay, but it's really just the whole system. And because looking at the whole system, I can't find the tension. Therefore, I have to split it up in one object, one object. So like one question, I can split up into 3 questions, looking at the whole system or looking at the individual objects. Yeah, and the most important step is the first step. The rest is just type in calculator only and moving around only. It's just maths. Okay, if everyone is fine with this, we'll wrap up this topic and we'll go into the next subtopic. All good. Yeah, I go on. All right. Resolution of forces. In this topic, it's a very short topic. Again, a lot of calculation. But resolution of forces is just the process of resolving a force into 2 components. Okay, resolving a force into 2 components. Resolve means to split a force. Okay, to split a force into 2 components. Components means like 2 parts like that. 2 parts like that. You know, earlier on in the last topic, we always try to plus the forces together, right? Remember, you can plus one force with another force, and then you find out the resultant force. Okay, using the triangle of forces method. In this topic, we are going to do the opposite. We're going to do the reverse. Okay, we want to know this purple color force here, this resultant force, is actually what force plus with what force. Okay, we want to know this purple color force is actually what force plus with what force. So from one force, now I want to do the reverse and be able to split it up into its original form, let's say. Okay, right? So from one force, we want to split into multiple forces. Right, let's look at this table real quick. Resolution of forces. Let's say you have this force. Okay, your force look like this. Somebody pulling something in this direction. Right, they ask you to split the force into horizontal component as well as vertical component. Horizontal means like the x-axis lah. That's why they say fx. Vertical means is standing up. That's why they call it fy. Yeah? Right. So what we will do is like this. Okay. Right now, this is like the final force, the purple one. Okay. And I want to find out if I have one person pulling the object. Okay, if I have one person pulling the object in this direction, what will it be, or how much force should I use if I have 2 person also trying to pull the object like this? Okay, I'm trying to figure out how much force should this 2 person apply so that it will move in the same way like this. Okay, we are trying to figure out how much force should this person apply and this person apply so that it is the same as the original force, right? So from one force, I want to split up into 2. Normally, we will split it up into the x-axis and y-axis, horizontal and vertical component. Okay, so yeah, don't worry about this first. I'm going to show you how to calculate that fx and fy. Later, you will see whether that it will all make sense and it will link back together from what you have learned in the previous topic. Okay, so bear with me first for now. You see, I am going to transfer my fy here. Okay, I'm going to transfer the fy here so that I get a triangle of forces. All right, same thing. I can just move it over there, no problem. The reason why I want to do this is so that I get a right angle triangle. Okay, and now I am going to focus on 2 of the forces only. I'm going to focus on F and Fx. Okay, I'm going to focus on F and Fx. Fy is here. Fy is here, but right now I don't want to calculate Fy first. Okay, I want to figure out what is the formula for Fx. Okay, what is the formula for Fx? I can use SOHCAHTOA to help me to find out. Okay, this is the hypotenuse. This is opposite of the angle. This is adjacent of the angle, right? Right now, we are using the hypotenuse and the adjacent. Right now, we are not using that one. Okay, so you write down SOHCAHTOA. Which one should I use? The one with A and H. Carl. The one with A and H. You see now? Carl. Right? So therefore, the formula for this one would just be cos theta equals to A over H. Okay, cos theta equals to A over H, which is Fx over F. And then I am going to multiply the F to the left side so that Fx is now F cos theta. Okay. Don't worry that if it looks very maths right now, that you don't feel very comfortable. Later, I'll teach you a trick on how you can remember this. Okay. And yeah, later I'll teach you. Okay, but this is how they derive the formula. Okay, at least I want to show you one time first. And then to find out Fy, I'm going to do the same thing. Okay, I have theta here, right? I'm focusing on Fy and also F only right now. I don't want to look at too many things. I have the hypotenuse. I have the opposite side. Which one should I use? O and H. So O and H. Okay, so it's going to be sine theta equals to O over H. Multiply this up to the left side. Yeah, so this is how this whole thing came about. Okay. Yeah, right now you will feel like, hey, why do we need to do this? Later I'll explain and I'll show you that it will all make sense and it's related to what you have learned in the last subtopic. Okay. If you are done with this, I will go through exercise 2.1. Okay. If you ask me, in my opinion, this one is not as important as what I'm going to do in 2.1. Okay. I need your attention in 2.1. This part is very important. If you understand 2.1, you understand the whole subtopic. Okay. If you understand 2.1, you understand the whole subtopic. Okay. Let's give it a try. To find out Fx, right, you no longer need to draw the triangle every single time. I'm going to teach you a trick. Okay, I'm going to teach you a trick. Your force is 200. To find out Fx, your 200 Newton, okay, I need everyone's attention. Your 200 Newton is going to close down this angle, right? It's going to close down this angle called 50 degrees. Close down the angle. Fx is equals to 200 close down the angle 50 degrees. Okay, close sounds like cos. I know it's very lame, I know, but bear with me. It will help you to remember and it will work every single time. Close down the angle should remind you of the word cos. So cos means close down the angle. What about sine? Sine means run away from the angle. Okay, run away from the angle. So let me calculate first. This is 200 cos 50, which is, you type in your calculator exactly 200 cos 50, you get 128.56 newtons. Okay. Let's try another one. Let's try for Fy. Again, I need your attention. Now 200 Newton You see, 200 Newton, this line, is trying to run towards Fy, is running away from 50 degree. The 200 Newton is running away from 50 degree. That's how you calculate Fy. So you don't have to draw the triangle and all that. If you remember the close down the angle and run away, this one, you will understand all the questions that you are going to do later on. Okay, close the 50 degree or run away from the 50 degree. Some people will also ask me, teacher, can we go and find out? Like some people, they feel like they don't like to use the sign. They feel like it's very hard to see the run away from the angle. Then they say, oh, can we find out this angle or not? Can also. This one would be what? 90 degree minus 50, right? Because whole thing is 90. Okay, this angle would be 40 degree. Right. Let's try and see. The Fy is also the same as 200 close down the 40 degree. $200 close down the 40 degree, you will get the exact same answer. You can try and see. Okay, 200 close down 40 degree is the same answer. Or you can try 200 run away from 40 degree is the Fx. Run away means sign. You will get the same answer. Okay, if you can understand this, everything you will know how to do it. The whole topic is talking about this one. Now, does anyone don't understand the idea of closing down the angle, which is cos? Okay, close is cos, and running away from the angle. Who don't understand, please let me know. I'll explain again. Because this is the backbone of the whole topic. All good? I was clear enough? All good? Okay, that's great. Sure. You can type both, they are the same answer. Okay, they are the same answer. And then for part B, if I want to find out Fx, okay, if I want to find out Fx, it would be 75 degree. Run away from 70 degree. Sorry, 75 Newton, my bad. Sine 70 degree. Because run away from 70, run away. Fy would be 75 degree. Close down the angle. Okay, that is the reason why the formula that we have created just now is just a general formula. It's just a general formula. Fx is not always cos. Fy is not always sine 1. You can't always follow this case. Because you take a look at our part B, Fx is sine. Fy is cos, right? So you need to understand the close down angle and run away, the one, then only you will be able to understand, right? Yeah, this is just my way of teaching it. Your school teacher maybe would ask you to draw every time and all. But in SPM, you can write your answer straight away like this. Okay, 75 Newton, run away from 70 degrees. 70 degrees. 75 Newton, go towards 70 degrees. Okay, so the final answer would be 70.48 Newton. Or 25.65 newtons. Okay. Next one, I want to explain, just give me 2 minutes, very fast. I want to explain this concept. So now we have figured out that, okay, one person pulling 75 Newton in this direction, okay, one person pulling in this direction, 75 Newton, is actually the same as 2-person pulling with a force of Fx is 70.48. Okay, Fy is 25.65. Now, one person pulling in that direction 75 Newton is the same as two-person pulling with this force, and the object will move in this direction. It will be the same. It will create the same resultant force. Okay, that is what we are trying to do. I know you have a lot of question mark because a lot of people say, teacher, this one plus this one is not 75 also, right? It is not 75. But you think back, in the last topic, when we learn it, is it that simple? Do we just plus together to find out the resultant force? No, you need to draw the triangle and all that. So I want to prove to you and see if I go and put all the force together. Okay, let's draw one by one. 70.48 Newton. We draw triangle of forces. Remember, triangle of forces needs to be in a continuous direction. Okay, so you walk to the left, and then you need to go down. 25.65 Newton. What is the resultant force? From the starting point to the end point. Can see not? Look at the arrow. Walk, and then go down. Walk. Starting point to the end point, that is the resultant force. That is your 75 Newton. How can we make sure? How can we double check? We can use Pythagoras theorem. Let's try and see. %, the answer is going to be 75. Okay, which relates back to what we learned at the beginning of last week's lesson. Okay, in the first topic. Okay, it'll be 75.00 something lah. Okay, but because we have rounded off the value already, right? By right, it's exactly 75. And so topic 1 was trying to combine two forces together, usually so that you get the result. You get the resultant force. This topic is trying to have one force so that you can split it up into two different forces. So it's just the reverse process. Okay. That's it for today. We're going to stop here. If you have any question, you can ask. If no question, you're free to go in here.